x square plus 16 is equal to 0. Then x square will be minus 16. But in previous example, good morning everyone. Today I'm going to teach you complex number, and in this video I will teach you what is a complex number and how we can represent complex number in Argand plane, and what is the basic terms and concept comes in complex number. In previous classes you have already learned what is real numbers and how many types of real numbers and how we can represent real numbers in number line. If we talk about complex number is very different to real numbers. Okay, for example, suppose that we want to find out the root of any quadratic equation. X square minus 4 is equal to 0. Then x square is equal to 4 and x will be root of 4 and x is equal to plus minus 2. So what is the root of x square minus 4 is equal to 0? We have find two roots plus minus 2. Similarly, if we want to find out the root of x square minus 16 is plus 16 is equal to 0, then x square will be minus 16. But we know only the root of positive number, but in this equation we have given minus 16. How we will find out the root of this number? So we can separate this x square will be minus 1 and 16. We know what is the root of 16. X square equal to minus 1 plus minus 4. Okay, plus minus 4. And in complex number and root iota हो जाएगा यहाँ पे. So what in complex number root of minus 1 will be iota. We can represent root of minus 1 in I, and I is iota. This is a imaginary numbers, and in any equation if we find root of minus 1, this will be always iota. So iota is a imaginary numbers. So next, iota and its power. What is iota and what will be the value of its power? So we know what is the value of iota? Root of minus 1. Okay, and what will be the value of iota square? So iota square is equal to iota multiply iota, and what is the value of minus iota? Minus 1 and root of minus 1. This will be root of minus 1 whole to the power 2. Square root cancel हो जाएगा. Then what is the value of iota square? Iota square will be minus 1. Okay, similarly we can find out the value of iota to the power 3. Iota to the power 3 is equal to, we can break iota to the power 3 is iota square and iota. What is the value of iota square? Minus 1 multiply iota. This will be minus iota. So what will be the value of iota to the power 3? Minus iota. It is clear? Then next will be, what is the value of iota to the power 4? Iota to the power 4, we can break iota to the power 4, iota to the power 3 and iota. We know what is the value of iota to the power 3? Minus iota and iota. this will be minus iota square. What is the value of minus iota square? This will be 1. So it is clear. And next we can find out the value of iota to the power 5 is equal to iota to the power 4 and iota. What will be the answer? What is the value of iota to the power 4? 1 multiply iota. And what will be the value of iota to the power 5? Iota. Similarly, we can find out iota to the power 6, iota to the power 7 and iota to the power 8. Okay. I wrote a small note. Iota to the power multiple of 4 will be always 1. If any number comes in iota to the power and this number will be multiples of 4, this number value is always 1. It is clear? For example, we have given for example iota to the power 102. Iota to the power 102. So what will be the value of iota to the power 102? Iota to the power 102 will be, if we divide by 4 102, to what will comes 25 plus 2. 2 will be remainder. Iota to the power 25 into iota to the power 2. So 25. And what is the value of iota to the power 25? Will be 1. And what is the value of iota square? So what the value of iota square is equal to 1. And the complete value of iota to the power 102 will be minus 1. It is clear? Similarly, given another example, iota to the power 3102. If we divide 3102 by 4, the remainder will be 2 and the value of iota square will be minus 1. The remainder will always goes in power of iota. Then we can easily find out the value of any biggest power of iota. And what is the value of 1 upon iota? Simply the value of 1 upon iota will be minus 1. But how we can rationalize 1 upon iota? We can multiply 1 upon iota upon iota. This will be iota upon iota square, and we know very well what is the value of iota square, minus 1, and this will be minus iota. It is clear? And the value of 1 upon iota, you can simply remember what is the value of 1 upon iota, minus iota. It is clear? And the next example is find the following: iota to the power 39 plus iota to the power 40 plus iota to the power 41 and iota to the power 42. How we can find out the value of iota? So we can see what will be the smallest power iota. So we can take common in this equation. So simply iota to the power 39 we can take common, then this will be 1 plus iota square plus iota cube, and the sum of 4 consecutive power will always 0. This will be 0. Yeah, we can say what is the value of iota to the power 39? 1 plus iota. What is the value of iota square? Minus 1. And what is the value of iota square? Iota cube minus iota. The terms will be cancelled. Then what is the value of this? And another example you can see iota to the power 55 plus iota to the power 56 plus iota to the power 57 and iota to the power 58. In this question, we can take iota to the power 53 common iota to the power 55. Then this will be 1 plus iota square plus iota to the power 4. And what is the value of iota square? Minus 1. And what is the value of iota cube? Minus iota, and then this will be 0. The note is sum of any 4 consecutive power of iota will be 0. If you have seen in any equation 4 consecutive numbers, then this will be always 0. It is clear? And another example is find the value of this. In numerator, you can take the smallest power of iota, and in denominator you can take common in smallest power of iota. In numerator you can see iota to the power 84 is smallest power, and then we can take common. So if we take iota to the power 84 is common, then this will be 1 plus iota square plus iota to the power 6 plus iota to the power 4 plus iota to the power 8. And in denominator, similarly, we can take iota to the power 574, and the remains will be 1 plus iota square plus iota to the power 4 plus 1 iota to the power 6 plus iota to the power 8 minus 1. And uh, this will be cancelled, and the value iota to the power 10 minus 1. And what is the value of iota to the power 10? So this will be, if we divide 10 by 4, so what will be remainder? 2. Iota square is equal to minus 1. And minus 1, this will be minus 2. And the value of this equation will be minus 2. It is clear? And the next will be, what is a complex number? We have read what is iota and how we can find out the value of iota's power. And in any equation, if 4 iota to the power comes 4 consecutive, then this will be always 0. And now we will come what is a complex number. What is a complex number? A number that can be expressed in the form of a plus iota b. Then the number is called complex number, where a plus iota b. We can represent complex number in the form of z. Then z is equal to a plus iota b, where a and b are real numbers and iota will be imaginary number. It is clear? A and b are real numbers and iota will be imaginary number. In complex equation z equal to a plus iota b, if in this equation b will be 0, then the equation will be z is equal to a. And in this equation z is purely real, because in this equation there is no imaginary numbers. It is clear? And similarly, if we take in this equation z is equal to a plus iota b, if we will take a equal to 0, then z will be iota b, and this is purely imaginary. It is clear because in this equation there is no real number. Then next, algebra of complex number. Okay, algebra of complex numbers means if we add two complex number, then what will be find out. Okay, so if we add two complex number, we will separate real numbers and we will separate imaginary number, then we can find out the equation of complex number. Okay, for example, if you have given 2 plus 3 iota plus 1 plus 2 iota, we will separate real numbers and we will separate complex number. So what in this equation, what will be the real numbers? 2 plus 1 and plus 3 iota plus 2 iota. Okay, so 3 plus 5 iota. This is a equation of complex number. It is clear? Similarly, the subtraction of two complex number. For example, 3z1 minus 2z2. Z1 and Z2 are two complex number. Then, for example, 3 first complex number is 2 minus 1 and second complex number is 3 plus 4 iota. Okay, we will multiply 3 to the 6 minus 3 iota minus 6 plus 8 iota, and we will separate real and complex number. 6 minus 3 iota minus 6 minus 8 iota. There are two opposite sign and same number, this will be cancelled, and 3 iota and minus 8 iota will be minus 11 iota, and this is purely imaginary number. And the third is division of complex number. Okay, division of complex number, if you have given two complex number 3 plus 4 iota and 2 minus iota. Okay, how we will find out the value? So we will rationalize denominator and we will multiply numerator and denominator, the opposite sign in denominator. So in denominator we have given 2 minus iota and we will multiply 2 plus iota and 2 plus iota in numerator and denominator, and this will be when we multiply 3 plus 4 iota and 2 plus iota, this will be 6 plus 4 iota square, and in denominator a plus b and a minus b, we can use this identity. This will be 2 square minus iota square, and 6 plus 4 iota square will be minus 1, then 6 minus 4 and 4 and iota square will be minus 1, and minus minus is plus, and 4 plus 1, and this will be 2 plus 2 upon 5. It is clear? And next is equality of complex number. If two complex number will be equal, what will be the value? So Z1 is first complex number a plus iota b, and another complex number Z2 is x plus iota y. Then Z1 equal to Z2, two complex number will be equal if their real number is always equal and their imaginary number will be always equal. So real number Z1 is equal to real number Z2, and imaginary number Z1 is equal to imaginary number of Z2, means a equal to x. If a equal to x and b equal to y, then Z1 will be Z2. It is clear? Concept of modulus, conjugate and argument. In complex number, z equal to a plus iota b is a point on the complex plane. It is clear. Suppose that you have given an example z is equal to 3 plus 2 iota, and what is the Cartesian point 3 and 2. We can represent 3 and 2 in Cartesian plane. It is clear. In Cartesian plane, x-axis is always real axis and y-axis is always imaginary axis. If we represent any real number, we always represent in real axis. Real axis means x-axis, and when we want to represent any imaginary number, we always represent in y-axis. It is clear. And what is the modulus? Modulus means, if we in Cartesian plane, origin and the point of origin is always 0 comma 0. The distance from origin to complex plane, distance between, if we have given any number in complex plane, the distance from origin to that number is called modulus. Okay, so suppose that we know what is the point of origin 0 comma 0, and if we have given any point in the complex plane z, a plus iota b, and we want to find out the distance. So we know what is the formula of distance, root of x2 minus x1 whole square plus y2 minus y1 whole square. It is clear. We use this formula and we can find out the value of modulus in complex plane. So this will be 0, first point is 0 comma 0 and another point is a plus iota b. So what will be root of 0 minus a square plus 0 minus b square, and this will be root of a square plus b square, and this will be mod of z, and the value of mod of z will be root of a square plus b square. It is clear. If we want to find out any complex number modulus, for example, you have given 2 plus 3 iota. So what will be the modulus? The root of z is equal to root of, what is the value of a is equal to 2 and b is equal to 3. So 2 to the power 2 plus 3 to the power 2, and what will be 4 plus 9, this equal to root 13. The root 13 will be the modulus of this complex number. The next is conjugate. Okay, conjugate means, if you have given any point in a complex plane, okay, in x-axis, so the mirror image of complex number with respect to x-axis is called conjugate. Suppose that you have given a number in a complex plane z is equal to a plus iota b, and the image of this complex